Imagine you're standing at a doorway holding a clipboard. When you run a program from the terminal, the operating system walks up and hands you a clipboard with two things written on it. How many items are in the bag and the bag itself? In C, that clipboard is the main function, and the two things are called argc and argv. Argc is just a counter, an integer that tells you how many arguments the user typed. It's always at least one, because the very first slot is reserved for the program's own name. Even if you type nothing else, argc equals 1. Argv is the more interesting one. It stands for argument vector, and it's really an array of strings. Each slot holds a pointer to a piece of text, the actual words the user typed. After the last real argument, there's always a null pointer like a bookend that says nothing more here. Why bother with command line arguments at all? Because they let one program behave many different ways without rebuilding it. Scripts automate tasks, pipes chain tools together, and you can configure behavior on the fly. That's the Unix philosophy, small programs that combine like Lego bricks. Here's our full program. We include dio.h for printf, then we declare main with the standard signature that accepts arguments. The function returns an int, which becomes the program's exit status. 0 means success. Inside main, the first printf prints argv0, which by convention is the name used to launch the program. If you typed /myprog, that's what shows up here. Don't trust it for security, though. Users can set it to anything. Next we print argc itself. Remember, this counts the program name too, so even with no extra arguments it prints 1. It's just a plain integer, easy to inspect. Here's a classic loop over the arguments. We start at index 1, skipping the program name, and walk up to argc. Each argvi is a pointer to a null-terminated string, so %s in printf just prints it as text. This is how tools like ls and grep walk their flags. And that's the whole trick. When you type something like gcc, while hello.c, the operating system splits that into argv pieces, and hands them to main. Argc becomes 4, argv0, is gcc, argv1 is wall, arg2 is hello.c, and argv3 is null. Your program decides what to do with each one. We will write, compile, and run a small C program entirely from the Linux command line. The program will print each command line argument along with its index, demonstrating how argc and argv work in a real C program. First we clear the screen to get a clean workspace, then we create the C source file using a here document, so we can type the program inline. Here we use echo with redirection to write the full C source into args.c. The program loops over argc, printing the index and the corresponding string from argv. Now we compile args.c with gcc. The compiler reads our source, produces the executable args, and returns silently with no errors. Running ./args with no arguments prints just the program name at index 0. This confirms that argv0 is always the path used to invoke the program. With 2 extra words, the program prints each one with its index. Index 0 is still the program name, index 1 is the first argument, and index 2 is the second. A flag-style invocation with flag value works the same way. The shell does not interpret these specially once they reach the program. Every token becomes its own argv entry. Finally, we use the file command to confirm that args is a properly built ELF executable. This verifies the compilation produced a real binary, not a script.